Well, it gives me great pleasure to introduce our next keynote speakers. One of them already got introduced, but we have Chris Preimesberger, longtime reporter and editor-in-chief formerly for eWeek, interviewing Ash Kulkarni, CEO of Elastic, one of the largest cybersecurity vendors. So, Ash, Chris, all yours.
Thanks very much. Here,
Ash is much more athletic than I am. I couldn't make that step. But anyway, Ash.
Good morning, everybody.
Yeah, good morning. How's everybody? Oh, Scott, we're getting a bigger crowd than you had. Oh, anyway, this is a lot of fun. And Ash, good to spend some time with you here.
Yeah, great to be here.
Looking forward to it. Guys like me, I'm a journalist, we are born with the skeptic gene, okay? I'm skeptical of everything, okay? I don't want to go into the list of things, but we want to see truth, and that's what we try to find is truth in what we write about. Because if we don't find it, we have no credibility, and it's the only thing I really have as a journalist is credibility, okay? I'm telling you the truth. That's why you're reading my story. Okay, so when I was invited to come up here and talk to Ash, I saw the topic and I thought, oh, this is great, but what the heck? Ensuring cyber resilience through visibility and transparency. Wait a minute. Cyber resilience, security rather, and visibility and transparency in the same sentence? I am highly skeptical of that. So Ash, I'm going to challenge you today. Explain a few things.
Happy to, but you know, when you look at titles, titles can connote all kinds of interesting things. But from my perspective, I just think back, I've been in the security industry for a while now, and what's really interesting about the security industry is, for the longest period of time, the whole mantra in security was, you know, that you wanted to keep everything as a black box. How do we detect threats? Well, we have some magic behind the scenes. We have some quote-unquote secret sauce that nobody knows about, but that's why we are better at detecting ransomware, we are better at detecting malware, behavioral detection, all of these different things. I think the problem with that whole philosophy is, fundamentally, machines have become powerful enough that as long as I can get hold of your software, I can reverse engineer it. And if I can reverse engineer it, there's nothing that stops me from knowing everything that I need to know about how you do certain things. So this idea of security through obfuscation just is nonsensical. It just makes no sense whatsoever. And our reliance on this assumption that we have to trust our vendors, we have to trust that their 1,000 developers or whatever have done absolutely all the right things, there's been no insider threat, there's been nothing that potentially could have leaked into their software, I think is fundamentally problematic. And if you are a modern InfoSec practitioner, you just go into it with the same kind of skepticism as a journalist does.
Okay.
And you effectively have to say, at some point somewhere, because social engineering is a thing, someone is going to make a very human mistake and click on something that they were not supposed to click on, do something that allows their environment to get hacked, and once somebody is in one application, in one system, then moving laterally is how modern attacks proliferate. It doesn't matter, you know, whether it's the Equifax one that was recently just in the past talk referenced, the SolarWinds attack that happened, Microsoft has had to deal with a few of these. Many of them start with either an insider or somebody that effectively gets popped, gets hacked. And so you have to assume that you are going to get infiltrated. And then the name of the game is, how do you detect it quickly? So that's where transparency, that's where visibility, I see it as bringing people into the light. Whether it's systems, whether it's identities, all of that matter. So that's why I feel that it's incredibly pertinent.
Okay, we're finished. That explained everything right there. That was great. Ash, can you define the term cyber resilience for me?
So to me, cyber resilience is a few things. So first and foremost, the preparation. You have to have a keen sense that you are going to get attacked at some point, And you need to really be completely prepared, whether it's doing red teaming, whether it's making sure that you understand your threat landscape and everything that you're doing in terms of defense. But then beyond that preparedness is how are you going to detect, how are you going to protect, how are you going to remediate, and then lastly, recover. So cyber resilience, I mean, there are good frameworks that have been defined around it, but what's really changing in this modern world is, there were some references about generative AI in the last talk, and this is what really, I believe, is going to change the way things happen today. So is there anybody here who's ever received a phishing attack, like some email that's tried to phish you? Great. What about smishing? That's a term. It's an SMS-based way to get to you. All right, most of you. Now imagine you getting a voicemail from your kid or your parent or your manager or your CEO saying something that is the moral equivalent of what is in that smishing text message or that phishing email, but now it comes with a voice, with all the inflections, the exact way they phrase things that tells you to do something. Are you more likely or less likely to do what you are not supposed to do? More. That's the problem. Because all of us, like right now, this I'm sure is being recorded somewhere. It's going to show up on the internet.
And is somebody going to spoof our voices? Ash?
You better change your voice right now.
Okay, from now on, I'm going to talk to him like this so that nobody can spoof me.
But that's really the problem, right? You think about it, we all have a digital exhaust. All of us have somewhere or the other our image, our videos, text, voice, it's all out there. It's out there in the public domain. And these large language models, I don't care if it's BARD, if it's GPT-4, like TiEcon, doesn't really matter. They've all been trained on everything that they've possibly been able to get from the public internet. As long as your information is out there on the public internet, they can use it to then, through these predictive models, generate content. Whether it's text, whether it's video, whether it's audio, what have you. And I think that's where like the bar now just goes up, because it means you should have an even greater awareness that everything that was possible through social engineering in the past to get into your systems is now going to happen with even greater frequency.
So how can we use AI, generative AI, for the good and against the bad guys? Because they're way ahead of us. They've always been way ahead of us. And they're out there spoofing people. I had a good friend the other day who got a call from his wife. Said she was in San Francisco shopping, and she needed some help for a credit card or something. And he thought it was his wife. She was spoofed. And he didn't follow through on it. It was a spoof. But they had her voice. And he was convinced. And like you said, if it's a family member or somebody who's close to you, you're more likely to do something. So how can we use AI for the good to protect ourselves?
In all honesty, if it were my wife calling and saying that she wants to spend more money on something, I might be like, I'm sorry, the connection's bad, I can't quite hear you. Just jokes, but bad jokes, I know. But like, it's so much greater if it's a parent or a child, somebody that really needs you. So these are like serious issues, and for everything, cybersecurity has always been extremely asymmetric. Believe it or not, the people that are trying to protect talk far less and collaborate far less with each other than the people who are trying to infiltrate. Like all these organizations, these advanced persistent threat groups, these APT groups that truly are trying to create damage, they have an amazing amount of collaboration between them. And all the machine learning that we have access to, they have access to as well. So what defensive AI, in my mind, is all about is, first and foremost, changing that asymmetry back in our advantage. And how do you get better advantages over them? First and foremost, by recognizing that they don't have an understanding of your internal systems. They don't have an understanding of your internal data. And all the AI and machine learning that they can potentially use has been trained on publicly available external data. Your strength is your data. So if I can take those same large language models or create my own, but let's just go with the flow and say, I take what is available through GPT-4, but then I augment those models with my private data. And there are ways in which you can do it in the safe confines of your infrastructure. So you're not, putting your data out there and allowing GPT-4 to then use it for other things. There are ways in which you can do this safely that now allows you to create these bindings between your private knowledge and these large language models. And with that, now you can use AI in a way that actually understands that even though certain things might be normal in an external context, they are abnormal in your context. And that's the best way to detect. And that's why transparency. So when I talk about the fact that, observability is incredibly important for being secure, it's because if you have all of this telemetry based on your data, now you have a much better way to defend yourself.
Yeah. You jumped ahead to my next question, which was circling back to the title. How in the world can visibility and observability fit into this picture? And you just started to touch on it a little bit. But could you go a little deeper into how it's used, first of all, with Elastic?
Yeah, so the way I think about Elastic is that we are an extremely scalable search analytics platform. To me, security is all about analytics. It's about making sure that you can identify all the signals out there. It doesn't really matter if it's data that's on your network, your application data, your identity and access management logs, your web logs, all of it. They are all telling you a piece of the story. Bringing all of that telemetry together and then correlating across it to have, from an identity perspective, a view of what is happening and what is happening that's atypical. How do you understand that better? And then based on that, and leveraging machine learning to say what is, even though it might be a weak signal, a potential indicator that there's something really nasty going on. That is the name of the game. And so, if you think about it from that perspective, you now want to use machine learning to even solve part of the problem that has always plagued the security industry, which is the problem of lack of enough cyber skills. This industry has always struggled with the fact that we just don't have enough technicians, technically savvy individuals who understand security. But there's a huge number of people out there who understand IT, who understand technology. Now, what if we made every single one of them capable of helping us solve security problems? What if I provided an interface where instead of having to define specific rules written in specific languages that are specific to certain cyber tools, I made it possible for you to go and ask the question, has there ever been an open connection between this particular application and the internet? Now, natural language processing and having a chat-like experience to your cybersecurity systems effectively changes that asymmetry once more in our favor. Because now instead of me relying on my CISO organization and the 10 people in that team who you've tasked with protecting, a 1,000-person company, now your entire IT organization of 100 people is able to be more effective and participate in that security process. To me, that's fascinating. That's a wonderful way to help augment all the efforts that we always put into the security world.
Very good. By the way, we'll have a few minutes near the end of our presentation for questions. So if anybody has one or a question, let us keep it in mind, and then we'll call on you in about 10 minutes, perhaps. So, after hearing Jeff and Scott earlier talking about machine-to-machine security, I think that's interesting. And we haven't talked about this, but how does Elastic fit into that? Does it help or provide a service or a solution for that kind of security?
Yes, so we take a slightly broader perspective that's somewhat orthogonal to what they are trying to do. So fundamentally, I agree with a lot of what was said about the fact that you need to think about things from an identity perspective. And identities, it's not just human beings and users that have identities, but even machines have identities, and you identify them in different ways. But what is most important is, techniques that have tried to secure by having allow lists and deny lists have always had problems. Because the moment, it just takes one valid use case where you should not have blocked something from happening, and then that causes, the whole program to go haywire. So allow lists, deny lists don't quite work. You need more dynamism in how you think about security. And so what we do is we provide this analytics platform that allows you to pull in all of your data, the machine interactions, the human-to-machine interactions, all of it. And then we help you analyze, correlate across all of that insight, and then say, here is what is anomalous. These systems should not have had any open connections between them. This user, who almost never does this particular pattern of connecting to the system, taking out some data, then moving it to some other application, just did that. And when you overlay that with physical security information, that might show that that user was never in that particular building or that location when that access was done. You tie all of those things together, and now you've got a problem. You have potentially either a system or a user that has been infiltrated, and you now need to act upon it. That's what we do. So for the largest organizations, the Fortune 500, the Fortune 100, financial services, large government organizations, Elastic is the data backbone. We provide that security analytics functionality, and because of our open source roots, Elasticsearch, the core technology that underpins everything that we do at Elastic, has been downloaded over 4 billion times. So it's massively out there, every IT organization, somewhere or the other, you've used Elasticsearch. That's what makes us so prevalent everywhere. And it's because we provide that capability to bring all your data together and then, get the needle in the haystack. But like somebody said to me, to be able to find the needle in the haystack, first of all, you need the whole haystack. And that's what we do. We help you get that information together and then get the insights quickly.
Wow, 4 billion downloads with a B?
Yeah.
That's a lot of downloads. Speaking about open source just for a second, as a former editor of Linux.com in the years ago, I have a great deal of respect for the open source community, and I've written many times. The world we have today would not be the same without open source software. I really feel that way, because so much has been built and built upon over the years. And you've built your company on that too. It's a perfect example of this.
Yep.
So nothing but respect for the community and for companies like yours that build on open source software. Okay, well, we can probably open it for questions. I do. I have one more question for you. Maybe just a quick answer would do. Is Elastic able to be used by line of business people at a company, or do you really need to be a security expert to use it?
No, so basically think of us as a platform, and we have purpose-built solutions that are built on top of Elastic for observability and security, and so those are tuned to those particular personas. Okay. So if you have an SRE, site reliability engineer that's responsible for observability and monitoring, they have an out-of-the-box solution, same for security. But Elastic gets used in all kinds of use cases. So if you ever use Booking.com and go and book a flight or a vacation or whatever, under the covers, they're using Elastic. Uber uses Elastic to map rider to driver. So the number of use cases for Elastic is across every segment. Cybersecurity accounts for about 25% of our business. Observability is about 40% of our business. But the rest is all these different kinds of search use cases, from e-commerce to workplace search around security, etc.
Yeah. That's what I figured. Thank you for that. Okay, do we have anybody that has a question for Ash while we're here? I see a hand up over here. I see actually in the fourth row, and then I'll come back to you. Go ahead, sir. Oh, good.
Hi, Ash. One question for you. So obviously, Elastic has implemented some use cases on top of the data that it gets, right? But obviously, if you look at security, right? If you look at recent Gartner's, what they're saying is look, there's data and then a lot of use cases on top of it, right? Hundreds of use cases. You obviously cannot do all of them. So is there an opportunity for companies to, in this world of AI, to kind of like build, the models that can be then be consumed by platforms like Elastic? And do you have a program for that where third parties can come and kind of like work with Elastic on that?
Yeah, so yes and yes. So absolutely, we think of ourselves as, effectively the platform with the relevance engine that allows you to build your new age generative AI applications. I don't really care what those applications are, because you're going to be building, I personally believe that we're going to see a whole host of applications from, healthcare to finance to, in every industry there's a need to improve the interaction model between human and machine. And generative AI, these large language models, lets you do that. And I expect that there's going to be a ton of development where these models become more domain specific, they become smaller, and you're going to see a whole bunch of these. A couple of years ago, we introduced the functionality in Elastic for you to bring your own transformer models onto Elastic, run them natively on data in Elastic. Last year, we introduced our vector search functionality, so about a year and a half ago. So, effectively, Elastic is a vector database. You can create vector embeddings, store them, and if you've ever used or played with large language models, you know the role that vector embeddings play in it. So absolutely, we want to be that platform that you can build all of these kinds of modern generative AI applications on and take advantage of the vector functionalities that we have. So just shoot me an email, connect with me, and I'd be happy to connect you with the program that lets you do what you're talking about.
So Ash, does this mean that Elastic is able to stretch around any kind of use case? Okay. You don't have to answer that, or you can if you want. It's okay.
This is wonderful. I mean, this is like actually giving me ideas on branding. So I appreciate this.
I'll send you a bill. Okay. All right. Here we go.
Hey,
Second
thank
question,
you.
Sir. Go ahead.
Yeah. Hi. My name is Amit. I run an early stage venture firm focused on cybersecurity and data infrastructure. And I think so. I just have one small comment that I think you talk about great possibilities because you are sitting at an intersection of SIEM, source, so many other data points, which probably between observability. I've always found this thing that observability has run as its own category, and security is its own category. Like now, players like you or Datadog or others are like saying, they're moving, so the security companies want to move observability side, and then this observability company, and this is, I think, great to sort of use generative AI to sort of kind of create that more seamless way to look at it cohesively, right? In that context, my bigger question is on shift left and seeing internally between DevSecOps and looking at the CI/CD pipelines for finding anomalies and code behaviors and others, and what is your view on how probably somebody like Elastic would do, or in generally the industry is thinking on software supply chain and things like that, because that's sort of the way of attacks, and you talked about insider attacks being one of the key things. So your perspective would be interesting.
Yeah, so I have a perspective. So first of all, everything that you said about observability and security makes complete sense, resonates very much with my thoughts. So we do focus quite a fair bit on helping you get visibility into your entire CI/CD pipeline, right? So this notion of DevSecOps, how do you make sure that everything from all the templates that you're creating, the code that you're checking in, and how do you make sure that, the new term that people talk about, like SBOMs, right? How do you understand like what's really in your software? But I have a slightly more potentially controversial view on this. And like my view on this is, all of that is goodness, and you should be doing all the code scanning that is appropriate, etc. But two things are going to happen. One is people are already using copilots like, GitHub has a Copilot. I think you're going to see more and more of these to generate code, right? And the problem once you start generating code is you are trusting something else to now do the things that you should have done thoughtfully and carefully. And I can play this argument on both sides. There are people who have countered by saying, well, but how good is your average developer anyways? Like, are they always thinking about whether or not they're introducing vulnerabilities? So I get all of that. But I think what's going to happen over time is, if we aren't mindful and thoughtful, we are going to start to, because of machines, potentially introduce more and more kinds of problems in our source code. So scanning and vulnerabilities potentially could proliferate even faster if we aren't careful. So it's going to be even more important, in my mind, to make sure that you have as many eyes on your code, and I don't mean just like visual eyes, like biological eyes, but openness is going to be the solution. Because the more things are in the open, you are not relying on just the engineers in your organization to guarantee that the code that you're putting out is safe. You are relying on the community. The power of the community is enormous. And when I talk about asymmetry, that those who are trying to do harm have an advantage because they collaborate better. Guess what? This is another way to change that asymmetry in our favor. If we collaborate by making sure that everything is in the open, why do you need to worry about, proprietary stuff? You've got great IP laws that ensure that whatever you're building is proprietary and you can protect it. You can defend it in courts globally. That's not why you should be making sure that everything is closed source. Open source gives you this amazing model. Doesn't have to be Apache 2, doesn't mean that you give it away. Think of it as source open, right? Where your source is visible. I think that's a very powerful model. I think that eventually is where security will end up, and that is how we will solve the real gnarly problems in supply chain security and so on.
Okay, we've got 1 minute left for one more question.
Thank you. Thank you, Chris. I have a simple question, not complicated like that. So my question is, security is very expensive, it's complex. So when we deal with big data, how do we strike a balance between security, performance, usability? What kind of innovation Elasticsearch is doing to strike that balance?
Yeah, so I think it's super important in whatever you do for data analytics to make sure that you're taking advantage of all the advances that we've made in cloud computing, in distributed computing, to make sure that you're constantly bringing down the unit cost of economics when it comes to securing any system. And that's really what we focus on. So I'll give you an example. A lot of our customers, they want to be able to store all their data for a long period of time, because in security, when the infiltration happens, the smart attackers don't do anything immediately. They stay dormant for months. And so when you're looking for threats, it's not enough to just look at last week's data and see, oh, something got alerted, like, do I need to act on it? The more important question to ask is, have I seen this pattern before? And before could mean for up to a year. So you need to be able to store your data and analyze it. But how do you do it without just it being ridiculously expensive? So we developed this capability that allows you to store all your data in extremely low-cost object storage, whether it's S3 or whatever, and then search directly against it, and reduces the economic cost significantly. But those are the kinds of innovations that is going to democratize security for everyone. I feel that that's what is going to really move the industry forward.
We're only at the beginning of all of this, too. This is the first inning of all this. So let's get started and you've helped us a lot. Ash Kulkarni, right here, the CEO of Elastic. Thank you for your time.
Thank you.